With the PATH program at UC Berkeley. PATH is a tortured acronym. It stands for Partners for Advanced Transportation Technology. They have some of the most renowned experts in the field of connected and automated vehicles. So it's a great partnership between our agency and academia. We were part of the National Automated Highway System Consortium, which was a $200 million federal program that operated from 1994 to 1998, culminating in a demonstration of vehicle automation that took place on Interstate 15 in San Diego. The highlight of that demonstration was a platoon of 8 completely automated vehicle savers that were traveling down Interstate 15 at freeway speeds. And in spite of the success of that demonstration and of the program as a whole, the federal government pulled the funding from the program before it completed its objectives, which was to develop specifications for an automated highway system. The next step was, in the federal program, was to work on a program called Intelligent Vehicle Initiative. Some of you may have heard that before. That ran for about 5 years and then was finally replaced by connected vehicles. So with connected vehicles, the objective is to enable vehicle-to-vehicle communications and vehicle-to-infrastructure communications, primarily to improve safety, but also with the ability to improve mobility and enable some commercial applications as well. That federal program has been going on since 2004, and right now there are 3 connected vehicle pilots going on within the United States. One is in New York City, one is in Tampa, Florida, and the final one is on Interstate 80 in a rural stretch of Wyoming. Those are federally funded projects, and I believe this is the year that they are supposed to go into operation and have an 18-month period of operation and evaluation to determine their effectiveness. At the same time, there was a federal competition for Smart Cities initiative that took place a couple years ago, and San Francisco was one of the 7 finalists. But the city that was chosen was Columbus, Ohio. So that city is now using its federal funding to develop the smart cities transportation components, and it's in progress right now. The major difference between connected vehicles and automated vehicles, and I think there's a lot of confusion about this, is that with connected vehicles, human drivers are always in control. They're receiving better information, better alerts, and if necessary, they're receiving warnings from the system that enable them to drive more safely and with less congestion. Automated vehicles are different because in the case of an automated vehicle, the machine is actually driving the vehicle. So there is, for those of you that are familiar with the 5 levels of automation, when you cross from level 2, which is driver assistance, and we had folks in the last session in this room that were talking about driver assistance systems, primarily the Intel representative. When you cross from driver assistance to level 3, which is automation, you have changed the responsibility for the safe operation of the vehicle from the driver to the machine. And that's actually a big change, and it's one that is challenging. So in a nutshell, those are the differences between the two. Now you can have automation with connection, and there's a lot of discussion about the potential mandate for vehicle-to-vehicle communication. The National Highway Traffic Safety Administration, in the final months of the Obama administration, actually submitted a proposed rule to require light-duty passenger vehicles to be equipped with technology for vehicle-to-vehicle communication. That rule is actually kind of in limbo right now, but some companies have moved forward with deployment of B2B communications technology. In particular, General Motors made a commitment in 2016 to do so, and last year's model of CTS, Cadillac CTSs, was equipped with that technology. In addition, Volkswagen in Europe has made a commitment to equip its vehicles with vehicle-to-vehicle communication technology starting next year. And a couple weeks ago, Toyota made a huge announcement about a commitment to equipping Toyota vehicles in the United States with B2B communication starting in 2021 model year. So there's a bit of momentum heading in that direction as far as and making that connection between vehicles and the infrastructure. There are several technologies that are competing for that, one of which is dedicated short-range communication, which is the technology that Toyota committed to. But there's also cellular V2X communication that is in the running. And it remains to be seen whether one, the other, or both are going to be the technology that's used for connecting vehicles. And today we're going to actually explore the topic of do we need to have vehicle connection in order to improve mobility in smart cities? And so I've worked with the panel on a couple of questions that I'm going to use to get the dialogue started. And then, as I said, eventually we were going to get to the point where we have questions from the audience. And I believe we have plenty of questions to keep us occupied probably for 3 or 4 hours. So one of my colleagues is, but we're not going to go that long.
Lunch is next, and I don't think that's going to work too well. We might lose some people.
One of my colleagues is going to give me the cue on when we're moving from the panel discussion to the audience discussion. So with that, I'm going to dive into the first question, and we'll work our way down, and then I'll get Dirk twice and have to come back. So the first question that I'd like to ask the panelists is, what is a smart city and what aspects of being a smart city pertain to transportation? And then what are some examples of smart transportation infrastructure? And should this infrastructure be owned and operated by the public sector, the private sector, or a combination of both? So Brian, hit it up.
Sure. Well, first of all, I think I've been working in the most bullheaded industry. You know, we're working in intelligent transportation systems now. I'm working in smart cities. You know, so I think this idea that what we're doing is so much better than everything else, I think is sometimes funny to people that don't know what we're doing. But I would say that it's no coincidence that intelligent transportation systems, that is where the Smart City Challenge was born out of. The ITS Joint Program Office was behind the Smart Cities Challenge. So I would say that many of our intelligent transportation systems that are out there now are probably some of the best examples of what smart transportation infrastructure can be. And you know, that right now includes dynamic message signs, vehicle detection. Now, some of the things that I think that are incredible and advancing in that area are actually coming from the autonomous vehicle industry, such as video analytics. The same video analytics that are going into vehicles and are part of the intelligent engines that are making deterministic decisions on driving are also now being utilized for vehicle detection on the side of the road. And that is because we're allowed to do edge computing, and the costs are coming down tremendously. So to me, those are prime examples of smart transportation.
So I guess being a car guy, I'm actually here to learn what you guys think a smart city is. I think of a smart city more from 2 aspects. One being safety. Making sure that once you have the intelligence in a car to enable the detection of things and stopping the car from running things over, things like that. I think that's definitely a benefit to a city as well. But also from the convenience standpoint, it's really hard to park in San Francisco. I want the car to just take off, go find some place to park, and you know, other things like that. Automatically order your food on the way to the restaurant, and the car just goes there, even the car goes for you, things like that. So convenience and safety, I think, are the key things for me.
I think from our perspective, being on the intelligent infrastructure side, to piggyback a little bit off of what Brian was talking about, there's a lot of space right now for an intersection between intelligent transportation systems and ITS and IoT. And so when I think about, what is a smart city and how that pertains to infrastructure, the first thing that comes to mind are all of these new devices that we're starting to introduce via pilots and some commercial applications as well, in terms of, radar detection, cameras that are capable of object classification. There's some really cool stuff that's being deployed for vehicle detection and for collecting new data streams. And all of that can also be harnessed to edge computing as well. So I think of smart cities pertaining to infrastructure, it really has to do with this merge between computing power and intelligence and live data that's collected in the field. And I'm going to take on that second question too, because I think it's a good one in terms of, who is the owner-operator of this infrastructure? Is there room for both public and private sector? And in my mind, there very much so is, and ideally in collaboration, that where these networks only enhance each other if you've got the public sector working in collaboration with the private sector, the public sector making space for pilots and demonstration opportunities, and the private sector coming in and assisting cities with technology applications and understanding avenues for monetizing.
All right. I thought about this first question for a little bit. What is the definition of a smart city? And to me, that would be a city that collects data and makes it available to the people living in the city. So any of the data that is relevant to the people living in the city. And there's always two areas how to look at this. And this is mainly convenience and safety. And when you're looking at the convenience area, this is the stuff that's already happening today. This is also the stuff that we're not going to stop. We can basically do what we want. We can try it with policy. We can ask for policy. Some of the questions are going in that direction. But the things are happening. I think we've heard the name Facebook this morning already. So this stuff is happening because people want it, and it makes our life more convenient. But what we're working on more, of course, because we're in the traffic sector, is, of course, safety. And in this area, to me, it's extremely important. But it's, in some cases, it needs help. We're talking about regulation, we're talking about standards as well, because it's not, for people, it's not so much about convenience. We always see the case that when you're looking at your car, you're more gonna check the box for the bigger stereo and the cup holders than for some system working in the background trying to keep you safe that hopefully you will never ever experience during the course of the life of the vehicle. And it's very similar with some of the things we're talking about here. We're talking about things that are working in the background, they're collecting data, they're making it available, maybe to the driver, maybe to the vehicle, maybe to someone else, keeping us more safe, but hopefully we'll never, even realize that they're there. And so that's why it's really important to explore this, to find out the areas where we have a common interest, and then focus on those, and then see what do we need to do in order to make it.
Thanks, panelists. Now, Dirk, you get first crack at the next question. So what are some examples of smart city transportation safety and mobility applications? And do these applications require both infrastructure and vehicle components? Does the vehicle component have to be built in? Or could it be retrofit, aftermarket, or even carried in, such as a smartphone? In addition to safety and mobility, are there opportunities for commercial applications that help to stimulate the economy?
Yeah, so basically my differentiation that I mentioned before also, of course, applies here between convenience and safety. And when you are talking about what kind of devices are we using, cell phones, everybody has them. For convenience, this is already happening. So that's the part that I mentioned that we don't have to worry about too much. But when it comes to safety, of course, you also mentioned the Smart City Initiative from Ohio. We're also working with those guys. We've got a couple of other pilots running. We are focusing very much on smart intersection projects, and that's a very good example. I think you mentioned this as well, because that's very safety relevant, because that's where most of the accidents in urban environments happen. There are many cases where you have to have connectivity to the vehicle so that you can either warn the driver, give him information so that the driver can react, or if we're talking about an autonomous vehicle, have an autonomous reaction of the vehicle to a situation that the vehicle or the driver cannot understand or not see. And that's exactly what we're focusing on. Building a complete environmental model of a static environment, very similar to what we're doing around an ADAS-equipped vehicle, which is dynamic, but we're doing this in a static form. And now the system will understand certain situations that are happening, certain risks, and then now they can intervene by informing the vehicle, informing the driver. And so in this case, yes, you need to have that communication. And I think for those cases, you want this built into the vehicle so that you always have access to it, and it cannot suddenly be turned off or left at home.
In terms of applications, I think there are many, both on the mobility side of things and also on the safety side of things. For us, thinking about connected and intelligent infrastructure, that lends itself very well to managing traffic congestion in a more efficient way. Being able to provide better prioritization for buses and other public transit, and also being able to enhance the safety of pedestrians. So we've got use cases around Vision Zero and things like that. I think being able to collect live information, and from our perspective, really the more information, the better. The bigger the data, the more granular the data, the better, is really what feeds and drives those use cases. And some of the things I mentioned before in terms of sensors and edge computing are really the backbone of what can make that happen or help make that happen within the city. I think I wouldn't say that the smart city necessarily requires both an intelligent infrastructure component and a vehicle component, but I think the two are very much so greatly enhanced with each other, right? And that you can operate intelligent infrastructure without a smart, connected, autonomous car. You can also run an autonomous connected car without that intelligent infrastructure. But if you look at the value add from leveraging both of those data streams and sources, both from a public and a private sector perspective, there's a huge enhancement there. If you've got vehicles communicating with infrastructure and receiving information about safety and traffic, and those vehicles are in turn informing infrastructure, helping traffic signals make better decisions. Again, initiate priority. I think there's a big value add there for everyone involved.
So a couple examples of things that I think are kind of interesting that I've seen. One is kind of radical, in my opinion. In China, they're looking at doing things like dedicating roads to self-driving cars for areas that are maybe to the airport, so from the airport. it's, but it's. And then the other one I mentioned earlier, I think is, again, a convenience issue. Make the car, find a place to park. You drive into the city and you get out and go find a place to park. And I think there's, to answer the last question, commercial application. I think new ways of offering parking spaces. I'm sure it's will work.
So in regards to examples of transportation safety and mobility applications, I think a good example is what project like what you're working on with connected vehicle on the multimodal applications, where we are exchanging what's called a basic safety message in the vehicle, and along with a signal phase and timing message, and by combining those can understand the trajectory of vehicles in an intersection, compare that to the timing of the intersection, and help prevent collisions. And I think that's a real good example of an interface between signals and how they operate in vehicles. Now, arguably, at some point, as we advance in our transportation development, vehicles may not necessarily need signals. They'll be able to communicate directly with each other. I think a good corollary to that is cellular telephones. So for the longest time, and still now, I still have to talk to a tower in order to call you on your phone, and you're right next to me. That's pretty inefficient. But as we know, with the advent of 5G and the next generation of technology, this phone should be able to communicate directly with yours. And I think that type of advancement is what we might be seeing in smart infrastructure.
Okay, Brian, you get the next one too. Is connectivity between vehicles themselves and vehicles in the infrastructure needed in order to enable smart city safety and mobility applications?
Absolutely. I can't imagine a world where vehicles are not able to exchange information with each other. One of the best things, and I use this in my presentation quite a bit, Dr. Steve Schlottover gave a really compelling argument saying that autonomous vehicles are only as good as they are connected. And I think that's very telling, because autonomous vehicles are only aware of their immediate surroundings, and there's exponential benefits that can be had when a vehicle can talk beyond the line of sight with vehicles ahead and get advanced traveler information. So, and it's good to see that autonomous vehicle manufacturers are recognizing that and are making their autonomous vehicles connected.
This is kind of a no-brainer.
That's a soft
I think this is really a key aspect for safety, actually. Sometimes you can't hear a fire truck or something. You want to be able to pull over safely, but if you don't hear it, you can't see it. But if the car knows and it just pulls over, it's like easy. So certainly all the different infrastructure, the emergency vehicles, the trains, the depot.
Just to echo my fellow panelists here, I would say absolutely the capacity for vehicles to communicate with each other, and to some extent we were just talking about in the last question, being able to communicate with infrastructure as well is going to be a really critical component. I mean, I think looking at potential outcome where that's not the case, we're going to have a lot of really great data floating around in silos that is not actionable whatsoever, both for autonomous vehicles and also for cities and the public sector too. And I think that how this plays out will be interesting to watch as well. From our perspective at RSM, being on the infrastructure side, we see connected infrastructure as being a really critical component, particularly in the next 5 to 10 years, where we're not going to have high saturation rates of connected and autonomous vehicles. And so being able to equip our infrastructure with intelligence, being able to equip our infrastructure with better data is going to be very important. And I think a key way to kind of bridge the gap from where we're at now with a relatively non-autonomous vehicle population to a future where we've got a lot of connected and autonomous vehicles on the road.
Yeah, I think I left a choice for my answer. But we're talking about the Internet of Everything, so I think it's pretty clear if I'm going to connect my refrigerator to the Internet, I might as well have on to my car. Connect to the Internet, and then by that, with everything around me. And safety, again, very important aspect, being able to communicate with the cars in front of me or around me, knowing what's going on, getting the information that they have. We're even looking at, potentially sending the camera feed from one vehicle to the next, so that you just, you can see down the road 300 yards, which is going to make things a lot safer. That's vehicle-to-vehicle communication, but vehicle-to-infrastructure, of course, as well. We will talk about the intersections, communicating with the vehicle. You have emergency vehicles, communicating with other vehicles, but also with intersections, for example, creating a corridor of green lights to go down, to make them quicker. So, yes.
All right, let me lob another pitch up that you guys can knock out. So, how important are national standards and specifications to the success of smart city transportation? And as a sub-question, should travelers expect their applications to work the same in every smart city? And what agency or agencies should be responsible for establishing these standards? So Dirk, you go first.
So, travelers will, of course, expect things to be the same there. And that's exactly the reason why everybody's basically using the same website on the internet, and they're using the same kind of phones, because it's just convenient, right? You don't want to change it. And so I would actually go a step further. You said national standards. I would like to see international standards, because people and vehicles are traveling around the world. I hope they will still do that in the future. We can still ship vehicles around the world. So yes, of course, in the interest of safety, in the interest of convenience, we must have international standards in certain areas. And that, of course, gets us to the question, who's in charge of that? And yeah, in the areas where this is not going to be happening by itself, just by consumer demand, we're going to need some sort of government regulation, and it's going to be somewhat different as a European, I'm allowed to say that. So I'm allowed to bring in the government. But in every country it's going to be different, but you're going to be looking for some sort of a central regulation to make sure that we're bringing these things forward as fast as possible. We've seen that in other technologies as well. I think airbags is a good one. Seat belts already a long time ago. Stability control systems in vehicles. Yes, and they have been mandated by, at the end of the day, the government, and to the good of all of us. And I think we're going to see very similar things here. If the technology is available, it's affordable, it's state of the art, we're going to see some of that, and I think it's going to be an advantage.
Again, to echo some of our fellow panelists here, I think certainly national standards and specifications are important. The public sector always has a role to play, both in protecting public safety and also making sure that there's a public benefit, particularly when there are city assets and other infrastructure involved. I think too there is a role for the private sector to play as well in terms of ensuring that there is ubiquity and some way for technologies to integrate with each other. To use the mobile phone reference once again, we've got multiple networks, many different carriers that are all operating mobile phone networks, but we can expect with some certainty that phones are going to work and we're able to call each other on them, that kind of thing. And I think having that same type of seamless integration as we start to introduce connected and autonomous vehicles will be very important. And there may be a bit of a gap there between what is mandated by regulation and what's really needed from a technological standpoint in order to make everything work. And so I think there's a role both for public agency in terms of regulation and private sector as well.
So definitely I think standards are necessary, but I maybe have a little different view of who should get them. Government seems to be very slow at making standards, which can delay the technology from actually coming into production. So the typical standard bodies like ISO an alternate option for some sort of adoption curve. I don't know, just a thought. Possibly with some government approval of that standard. Just about that, because I see things like B2X just getting for a standard. I just don't see the interest to make it go faster. So, a little bit.
Yeah, short answer, yes. And I think standards are come out of a necessity in order for it to have interoperability. There is an IEEE standard. I believe it's P2453 or something like that. And there's another 2030 that. 1609. No, that's the wave. That's the wave I'm talking about for Internet of Things. These are newer standards. There is IEEE 2030 as well. These are newer standards that are addressing the interoperability of what we're calling smart cities. And that is meant to bring down the barriers between disparate types of communication systems to allow the exchange of information. So there's still frontiers yet to cross. And I think another big example too, and the elephant in the room is standardization of autonomous vehicles. And we're hearing some of this in the news in regards to how can you evaluate machine learning. And that's just a new frontier, it's like, it's something that's being developed and perfected on a daily basis. So those are, definitely need to have standards, and I think we're going to see more of those.
Okay, thanks, panelists. I'm told by my colleagues that it's now time for questions from the audience. So hopefully you've been saving up all those burning questions. And there's folks with microphones that are ready to give you an opportunity.
It seems like one down.
Sorry, would you introduce yourself first?
Yeah, Ken Pyle, BODPO. It seems like one challenge with connectivity, once you start connecting things, is the chance for cybersecurity risks and things like that. Curious what your top thoughts are on that. Is there some kind of blockchain type solution to that, or how do you identify that it's a good source, not a bad source?
That actually was one of the questions in my 2-page list, but we didn't get to it. So thanks for bringing it up so I can give the panelists an opportunity to dive in.
Well, there's the security credentialing management system that's part of the framework for a connected vehicle, and that's part, I believe that is in each of the 3 pilots, right, Gary?
Yes.
Yeah, so each of the pilots is evaluating a mini version of that. And the thought is that this system will will credential the packets of information that are being exchanged. So it's definitely something that has been thought. Now, does that mean that we are resilient to cyber attacks? No, I think we have to see some challenges with that, like the internet did. So, but out of curiosity, how many people in the room have had their computer hacked within the past month? Okay, we got one person. I think if we were to go back maybe even 5 years, we'd have a decent number of people that would have been part of that. So I'm hopeful that as we introduce these types of vehicles, we'll have some hard lessons learned and we'll develop some improved firewalls.
Go ahead.
So one of the things that car companies are doing is looking at safety safety in the aspect of the security problem, and not allowing the car to do things that seem abnormal. And so I think that is also a critical function that must exist as well.
Hi, I'm Dave Lemmer from Santa Rosa Junior College, and I have I'm looking at the what can go wrong after, say, a collision in a car. So I was in a discussion with an instructor teaching collision repair, and he's looking at a scan tool, which is another computer which interfaces with the car, and he comes across this camera, recentering. He's like, oh, okay. So he touches, taps on it, and he goes there, and it has grids, so you can see what the camera is seeing in the scanner, and it has to be recalibrated after a repair. If something gets bumped out, then, so now I'm seeing, like, down the road, there's all this connected vehicles, connected infrastructure, relying on some inaccurate information from a camera, say. And so you're all familiar with the garbage in, garbage out. And so there's thought being put to, someone's trying to hack in and deliberately put some false information in there, but then we also have to be concerned with the information it could just be inaccurate. And how do we deal with that? So I was wondering if anybody had any thoughts on that.
Looks like Dirk's ready to go.
Yeah, maybe I can take a stab at that because, you did mention that in the beginning, but I've been with this company for 25 years, so I've been around for a while, and we've been dealing with these things, of course, a lot ever since we started putting sensors on vehicles, and it starts with very simple sensors like wheel speed sensors, and then go on to cameras, radars, lidars, and I think that's exactly what you're referring to. And of course, you have these algorithms in there to calibrate these sensors. And the first time you have to do that is when they leave the plant. The next time you do it is when they're getting installed in the vehicle. On some of them, you may have to do that on a regular basis, and especially after an accident. So this is something that's happening always. And these are things that are keeping our engineers very, very busy. And that's why we have such large numbers of engineers. And that's also the reason why many of the companies who tried to get into this space in the last few years, especially from this area here, had to realize it's not as simple as just putting one car out on the road that actually makes it around the city halfway decent. If you want to sell a few million of these, you have to get all these things right. So there's algorithms there that do the calibration, but they also do the plausibility to check the data. Is it accurate? Is it plausible? Can we believe this data? And we're now in the process of transferring this to the infrastructure, to the static sensors, doing a similar thing. So it's going to be code in place to ensure that this doesn't happen. Of course, there's never a 100% guarantee, but looking at what we have in vehicles today, I'm pretty sure that most of the scenarios we're going to be able to catch from a, let's say, accidentally bumped sensor kind of a viewpoint. The cybersecurity point is, of course, a totally different.
Just to add to that, I would say there's a really important role for data validation. We've got a pilot going on here in San Jose, and that's been one of our key issues in the first 6 months is looking at validating the information that's coming from our radar sensors with trusted sources, with a ground truth source. And I think that if you've got, wherever you have your sensing systems mounted, whether it's on infrastructure or vehicles, there does need to be a way in early stage development to make sure that those sensors are accurate, right, and collecting accurate information. And then, I think a great question moving forward, particularly as this industry grows, is how do we continue to make sure that there are best practices around that, so that it's very well known that a part of vehicle maintenance, autonomous vehicle maintenance, is to ensure that all of those sensors are ground truth. And we've been developing systems to ensure that that things happen in a certain way for a long time. So I think that some of those same models can be applied here as well. It's a maintenance thing.
Okay, we have another question. Yes.
So it's James, City of Santa Clara Planning Commission. It seems like a lot of the discussion about these connected cars has been around safety, which should be the priority. My concern is about traffic, and you have vehicle-to-vehicle connectivity, and then you have vehicle-to-network connectivity. So my question is, of course, it's an optimization problem, which is computationally very complex to optimize traffic with all the signaling and everything. What can we expect in terms of closer vehicle distances and optimizing the amount of traffic? Can we get 30% more throughput through our cities with these connected vehicles? What kind of performance do we expect?
So that's as far as the focus on safety and the movement to mobility, that's a trajectory that we're going right now, and that's been sort of pushed by the Joint Program Office. The focus first was the safety pilot. It was called the safety pilot, and it was really kind of the first effort to validate this framework of the connected vehicle. And I think the next generations here, we're going to see more and more applications that address mobility. As an example, Jacobs is working on a project with the Port of Oakland to optimize goods movement, and part of that installation is the development of a smartphone application that will allow truckers and dispatchers to get better near real-time information on the movements within their own world of the port. And regarding your question about the ability for vehicles to get more throughput, I'm not aware of the specific percentages of improvement, but essentially what we're looking at is an exponential improvement in the capacity of a roadway by it being connected and autonomous.
So I'll take the moderator's prerogative and respond to that as well. And again, I'm a researcher, so some of the stuff we do does not see the light of day, but we've done research with our colleagues at UC Berkeley PATH on connected or cooperative adaptive cruise control. So that is adaptive cruise control as a component of communication between vehicles. So potentially, and I talked earlier about the 8 Buick Sabres that were connected and automated back in 1997, but potentially if you have strings of cooperative adaptive cruise control enabled vehicles, you can get very high throughputs on existing freeway lanes. And again, I'm talking about freeway here. So simulations suggest at least double the capacity of the existing lane. So 2,000 vehicles per lane per hour is conventionally the ideal with manually driven vehicles. So potentially 4,000 vehicles per lane per hour on a freeway is capable with long strings of cooperative adaptive cruise control vehicles. That still has to be tested in the real world, but in simulation and in small scale, it has been verified.
Quick add-on from the corridor perspective as well. One of our core objectives with this demonstration project here in San Jose is to basically simulate efficiencies at an intersection in the North San Jose Transportation Innovation Zone. And RSM's core business is to leverage computational intelligence in order to help signals make better decisions, essentially. And so, we basically took live data from Tasman's Anchor and created a simulation of what the intersection would look like. What would those dynamics be? What would the signal phase and timing look like if the intersection was run using our system, using a fuzzy logic computational intelligence-based system versus traditional adaptive management. And just very preliminary results, we were able to increase intersection efficiency by around 10%. So if you think about what that means for one intersection, the potential to add network effects, which may end up increasing or decreasing that percentage, we believe there's really good potential to reduce traffic congestion significantly by adding an intelligence behind traffic signal operation.
So I'll take the moderator's prerogative and respond to that as well. And again, I'm a researcher, so some of the stuff we do does not see the light of day, but potentially if you have strings of cooperative adaptive cruise control enabled vehicles, you can get very high throughputs on existing freeway lanes. So potentially if you have strings of cooperative adaptive cruise control enabled vehicles, you can get very high throughputs on existing freeway lanes.
Maybe just two more comments. One is there is a direct relationship also between safety and traffic efficiency, because when you listen to the radio in the morning, the biggest problems that we have is accidents. So every single accident that we avoid is going to be, let's say, a step in the right direction, making traffic better. The other thing is, all these things are going in the right direction. We're going to be able to, put cars into road trains and send them down the road. It's going to be very efficient. That's going to take a lot of time until we have enough vehicles out there with all this technology on there. At the same time, we're going to have a lot more autonomous vehicles out there, because now suddenly the pizza drives itself. It doesn't require a driver. And all these things, we're going to order a lot of stuff online. It's going to be delivered by a car. So I think that's only going to make it worse. So the one thing that we have to keep in mind is, that goes back to the keynote this morning, is we're going to have to get people into mass transportation. We need more people in one vehicle, preferably in a bus, so that we have 50 people in there. That's extremely important that we don't forget that. It's not, with all these things that we're doing, it's not just going to go away and be great. We can still all drive in our big SUV by ourselves. We're going to have to do things differently.
San Jose. Hello, everyone. Before I ask my question, I just wanted also, as a public servant, put out that the Justice Department did put out an alert around resetting your routers because of a hack this past week, in case you missed it. My question is back to cybersecurity. You know me, you know that I'm really passionate about this area, and as we bring more devices online, one of the most troubling things that someone told me once that is a professional hacker is 64,000 new ways to get into a city infrastructure, into the city system, if we start putting up connected devices. I see a lot of companies addressing cybersecurity in silos around their own products, doing their own bounty programs, all these types of things. What types of things are happening on the international standards community or between partnerships between industry to start looking at this holistically rather than as an individual entity?
You've stumped the expert panel.
I think that's a great question. I can answer it from a kind of from a systems perspective, right? If you think about, we've got an intersection with maybe half a dozen different connected devices there, also maybe wrapped into city infrastructure in some way, shape, or form. And I think there's, again, a lot of room there for collaboration in the private sector to really solve cybersecurity challenges. And we're pretty familiar with what it means to design security for networks, and it's going to be, my assumption is, a very robust version of that, because of course you've got city assets involved and some significant risks that is a little bit different than consumer applications. And so, in my mind, it's just one more reason why it's good for the private sector to really get together and think through some of these smart city applications before bringing them to market, and making sure that we all know how to work together, both from a data perspective and from a cybersecurity perspective.
Maybe one more thing. In the automotive industry, where I don't know if you're familiar with functional safety management. This is basically a process of ensuring that all the different functions in automated driving or assisted driving are inherently safe. And this process is basically used all around the automotive industry. We're seeing similar approaches now to cybersecurity, to design in cybersecurity, to look at the software that you're coding in a certain way and go through systematic steps of doing it. It's not going to be perfect, I'm sure, but that's definitely an approach that has worked already on the functional side.
All right, I'm told that we're finished here. I want to thank you for your kind attention. I'd like for you to join me in giving a round of applause to our expert panel.